Okay, let's now understand the ionization of a weak acid. Okay, so ionization constant we are trying to get for weak acids. So, like I mentioned earlier, equilibrium is only seen in the case of weak acid dissociation. For a strong acid, there is no concept of equilibrium because the salt is completely ionized, dissociated to give you ions. Okay, hardly there is any backward reaction that is happening, or in other words, the reaction is almost completed. There is no concept of equilibrium in case of strong acids or a strong base. Equilibrium comes into picture only when you are having weak acids. So in case of a weak acid, what is the meaning of ionization constant? And we call it as Ka here because K is equilibrium constant, which is nothing but ionization constant. If the reaction is an ionization or a dissociation reaction, A here represents acid. Okay, it's just the naming, otherwise it's as good as equilibrium constant. So let us consider a general equation Hx, which is a very weak acid, okay, in the presence of water, that is liquid, it it ionizes to give you H3O plus ions and X minus ions. Okay, both are aqueous. Now, what is the meaning of ionization constant? I'll write it here. So this Ka is nothing but, if you follow the standard definition for ionization constant or equilibrium constant, it is the concentration of products, the ratio raised to their powers divided by, I cannot consider water because it's liquid, its concentration is fixed. So I will just consider the concentration of Hx. Okay, this is one way. If you know the concentrations, directly substitute, you will get it. But most of the times, questions will be given like, you had some initial concentration, something was, after equilibrium, it was found that this much got dissociated. They'll give you questions like this. The data will be in this format. So that's the reason we have to, now I will just give you the overall logic. Then we will directly take up a question, and that time only then all this concept will be clearer to you. Okay, so let us now, I will just, the same thing is we are going to do for bases also. So first, if you understand this, that part is sorted. Okay, so let us say the initial concentration was C. I started with C molar Hx or some weak acid. So initial concentration of product will be 0. Okay, so let us say extent of dissociation. In some questions they give you this. Okay, so what is the extent of dissociation? If I am taking 1 mole of the reactant, that is Hx, how much got dissociated into H plus and X minus ions? Okay, so the extent of dissociation is called alpha, and this alpha is always for 1 mole. So we are having C moles here, so you will write C alpha. If 1 mole is dissociated into, for 1 mole, if the dissociation is X or X moles got dissociated, you are taking C moles of Hx. So for C moles, it is C alpha. I will write a minus sign here. Okay, I'll tell you why. Now, if alpha is the rate of dissociation or extent of dissociation, that means out of C moles, X, or I'll give you an example. Let us say this was 100. Out of 100 moles, let us say 10 moles got dissociated. And since the stoichiometric coefficients are 1, for every mole, you are getting 1 mole of this, 1 mole of this. Correct? So if I started with 100 moles and if there is 10 moles which got converted, so that means there is 10 here and 10 here. Correct? So here it will be C alpha and C alpha. Alright, so I repeat, and here I will write a plus. I will tell you the significance of plus and minus in a while. Okay, so I repeat, because this you understand correctly, base is just going to be a copy paste. Okay, so I initially started with C molar concentration of Hx, and alpha moles per mole of the reactant got dissociated. So for C moles it will be C alpha, and if 1 mole got dissociated, I was getting 1 of this and 1 of these ions. So if C alpha moles got dissociated, I'll be getting these many ions. I hope it is clear. Now, concentration at equilibrium. So I started with C moles. C alpha moles got dissociated. What is the remaining quantity? C minus C alpha. Here. and here it is just a C alpha, because initially had nothing. Whatever is there, and let us say an equilibrium was achieved, the same would be the concentration of the products. Okay, so now if I write an expression for Ka, so all the numericals you're going to make a table like this and just apply the regular formula. You don't have to memorize this formula, I'm just writing it. Okay, so this is the equilibrium concentration of the product into C square alpha square, because if I multiply these two, this multiplication, right, divided by concentration of the reactant. So 1C gets cancelled. So it is C alpha square into 1 minus alpha. Okay, so this will be the, this is how you find the equilibrium constant or ionization constant of an acid, weak acid. A just represents acid and this is it. Don't memorize this. You should know how to write this table and you are sorted. Okay, now there are rules to find the ionization constant and it's exactly what I have told you. The rules are there in your book, you can go through it. What I will be doing is, I will be teaching you how to apply these rules with a real problem. Okay, I will take up a numerical which explains all these concepts and also the rules which are mentioned. Okay, because just telling the rule is not going to make any difference. We already have studied this now. The same thing is just formulated as a rule. Okay, so I'm just going to take one example based on calculating the ionization constant of a weak acid. This is 7.18 of your textbook. Ionization constant for HF. Okay, ionization constant for HF is given to you as 3.2 into 10 power minus 4 molar. Okay, ionization constant, no unit, sorry. Calculate the degree of dissociation. You have to find the degree of dissociation. That means you have to find alpha, okay, of what? Alpha of HF in 0.02 molar solution. That means this is the initial concentration. Okay, 0.02 molar solution. Calculate the concentration of all species and its pH. So you also have to calculate the concentration of all species and also their pH. So if you know the concentration, you can find the pH. Okay, so first of all, let us understand what is happening here. So what is given, let me write it. Ka is given to you because it's an acid. HF is a weak acid. So Ka is given to you. I'm writing it as Ka. C is given to you, initial concentration. Okay, this is given to you. You need to find alpha. What is a value of alpha? You need to find the concentration and also the pH. I hope it is clear. Now, let us write the reaction. So, what is the reaction? That is a weak acid and it is getting ionized or dissociated into hydronium ions plus fluoride ions. This is one. There is also a reaction which is happening every time. That is, this is giving you H2H3O plus OH negative. Okay. Now, the rule says that, first you will write all the data. Okay. And then you will write the reaction. And then this, this is the ionic product. It is 10 power minus 14. What is the Ka here? Ka here is 3.2 into 10 power minus 4. Whichever reaction has the higher Ka value, that will be your primary reaction. So in this case, this is my primary reaction. This is my secondary reaction. Okay, so once you write all the reactions, depending on the value of Ka. Now again, I forgot to tell you, if the Ka is higher, that means it's a stronger acid. Remember that. Sometimes they can ask you in 1 mark. Okay, let us say there are 3 acids, which is stronger. Stronger the Ka, stronger is the acid. Why? Ka means concentration of product. If Ka is higher, there is more concentration of product. That means the acid has dissociated more. Alright, now let us, the steps, I was mentioning about the steps. The steps is you write the reaction and then depending on the value of the Ka, whichever is lower should be the primary reaction, and most of the times this will be a primary reaction. The reaction of water will be in most of the cases secondary reaction. Okay, so this is my primary reaction. Now for the primary reaction, write all the tables. So what was the initial concentration? 0.02 moles and this was 0. Okay, I'm writing for this reaction. Okay, I'm writing, I'll just erase this so that you don't get confused. I'm writing the table for this reaction because this is my standard reaction. Okay, so initial concentration, let us say the degree of dissociation is alpha. So what it will be, C alpha and alpha, C alpha and C alpha. Okay, 0.02 alpha. So this is my degree of dissociation. Concentration at equilibrium. What will that be? 0.02 minus 0.02 alpha. Okay, this is the concentration. This is 0.02 alpha, 0.02 alpha. Like I told you, this is going to be plus because initially it is 0. Okay, so this you are familiar. Instead of C, it is 0.02 here. Now what do we do? The same process, nothing new. They have unnecessarily given you all the steps, but we know already how to do it. Right? So what is my Ka? Concentration of the product, which is 0.02 alpha into 0.02 alpha divided by concentration of the reactants, which is 0.02 minus 0.02 alpha. Okay. Now, if you take something common, one of them will get cancelled out. And I know my Ka, right? So I can easily find out my Ka here in that case. Okay, so Ka I know, I can find out alpha, sorry. So this is 10 power minus 4. If I take, this will be 0.02 into 0.02 alpha square by, this is equal to 0.02 into 1 minus alpha. Okay, so one of them gets cancelled. And if you cross multiply, you'll get a quadratic in alpha. Okay, I'm just writing the same thing what you have. You know how to solve it from here. So this is your alpha square and alpha. I get a quadratic in alpha. If you solve for alpha, you will be getting alpha is 0.12. Okay. Now, in order to find the concentration, yes, what was the concentration of H3O plus? It was right here. I erased it. Concentration of H plus or H3O plus, both are same. That is will be 0.02 alpha, which is 0.02 into 0.12. What will that be? That will be 2.4 into 10 power minus 3 molar. This is the concentration of hydronium ion. What will be the concentration of, what was this? This was fluoride ions, right? So the concentration of fluoride ions will also be the same because both of them are having the same stoichiometric coefficient. And what will be the concentration of, what else was there? I think the reactant, that is HF. It will be 0.02 into 1 minus alpha. You will just substitute the value of alpha here and you should be getting 17.6 into 10 power minus 3 mole. Okay, I'm just taking this value, it's just calculation. The last step was what is the pH? pH is nothing but this concentration. So if you want to calculate the pH here, pH in this case is negative log to the base 10 of the hydrogen ion concentration, that is 2.4 into 10 power minus 3. I have told you how to split this in one of the videos. Minus log, this will be log of this plus log of this. Take the power out and then multiply. You should get it as 2.63. Any issues with the calculation, you can let me know. It's all basic calculations, so I'm not getting into the details here. Okay, so this is how you calculate the equilibrium constant or ionization constant Ka of an acid. And if the Ka is higher, more stronger is the acid. Now there is also a term called as pKa. If I know Ka, I can find something called as pKa, which is minus log to the base 10 of Ka. Alright, so I can readily find it. Let us quickly do it for bases as well. I'm not going to do a numerical here because exactly the same thing. I'm just going to tell you the concept. Okay. So if you have a weak base like this is ionization constant for a base, and for base we say Kb. Ka represents just a representation, right? So ionization constant or equilibrium constant for an acid, Kb is the equilibrium constant of a base. Okay, so let us say it is giving you metal. This is metal hydroxide. So metal ions plus hydroxyl ions. So what will be your Kb? Kb will be the concentration of metal ion into OH minus ion divided by concentration of the initial base initially, right? So now again the same table you are gonna do, all right? I will just tell you orally. You will write initial concentration alpha, that is extent of dissociation, equilibrium concentration. So this will be C0 and 0, okay, products, and here it will be minus C alpha and C alpha. Just have to subtract C minus C alpha, C alpha, C alpha. That's the reason there is a plus there. What it means initially was C. Alpha is the extent of dissociation, which means per mole how many moles got dissociated. It all depends on how strong or how weak the acid is. If for every mole of the reactant, how many moles got dissociated, that is alpha. And whatever got dissociated, same will be the product if they have the same stoichiometry. Otherwise, you will raise it to the respective powers. Okay, and then if C moles, this many moles got dissociated, what is remaining at equilibrium? Exactly the same thing. Okay, so this is my KB, and then you will calculate, of course, all of that, the same thing. Ka will be this into this divided by this. Refer my notes if you want, but exactly the same thing. And I will have again the same thing. If Kb is higher, that means stronger is the base. Kb is higher, stronger is the base. And you can also find something called pKb, which is minus log of Kb. Okay, so this is how you calculate the ionization. Isn't it the same thing, right? That's what I told you. Once you get the grip of what an equilibrium constant is, these are just fancy names specific to acids. We say ionization constant, equilibrium constant. Everything is going to be the same. If it is acids, we say Ka. If it's base, we say Kb. Ultimately, it's the same thing. Concentration of product of the concentration of product raised to the power divided by product of the reactants raised to their powers. And if you do not know this data, you should know how to write this table. Initial will be given to you, product no initial. If alpha moles got dissociated per mole of the reactants, for C moles it is C alpha. Whatever got dissociated, same number of products were formed because they all have one stoichiometric ratio. Then you will figure out what is the concentration at equilibrium. Once you know this, put the equation just like I have done in acids, solve it, you will get alpha, then decide what you want to, then you decide what needs to be done. Okay, so I hope this is clear. So I have a question on base, maybe you can look at it later, it's there in the book, or any other questions from your textbook, because in detail I have done it for acids. Exactly the same thing is going to be the case for bases also. Okay, so yes, with this I wind up this. So next we will be understanding the relationship between Ka and Kb.